Okay, I just have a question for Steve. The catalysts you're talking about, are they simple, cheap catalysts, or they require complicated metals? And as a follow-up, are we going to be able to get out of lithium? I saw your slide, but it looks like to do anything useful, you still need lithium or not?
The answer is we tried it with the standard catalyst, but there's lots of work on much cheaper catalysts based on nickel iron. In terms of lithium, we are about to submit a paper where we can get lithium from salty water, including the water that comes out of when you get for oil, and also seawater. So the resource of lithium has just increased about 10,000-fold.
Bonfire.
As a total ignorant about these issues of energy, I would like to ask the two speakers, why is there such a complete silence covering the prospects of nuclear fusion as a source of clean energy? Is it that one has given up? Or that, why is, I've heard for several decades that nuclear fusion was a possible source of clean energy. And now I don't hear anything about it. Is that one has given up, or is it possible? Or?
Let me comment on that. It would seem to me that the future of energy is not in nuclei, but is in the atoms, in the physical processes. We have discovered a huge amount of natural gas developed in various occasions. We have clathrates, for instance, produce a huge amount of natural gas for thousands of years. And natural gas is certainly a big step forward because it reduces by a factor 4 the amount of CO2 with respect to coal. However, I am trying to explain, I hope that my presentation arrived to you, that there are methods in which you can reach natural gas without CO2 emission, by concentrating yourself into the situation in which there is carbon, black carbon plus hydrogen, and hydrogen then is transformed into a liquid like methanol or ethanol or whatever you need to have. Therefore, it would seem to me the nuclear problems, because of their complexities, in particular the existence of radioactive material and so forth and so on, are not an alternative option, which makes sense with respect to the availability of a large amount of resources, most natural gas, which is clean, and which can be done with reducing the consumptions of CO2 by a great amount.
Let me add to this very quickly. We haven't given up. Fusion is extremely difficult. There's large multi-international collaborations trying to pursue that. There are actually about 10 private enterprise companies trying to do this. I'm a scientific advisor to one of them, and I know personally, I tell you, it's very, very hard. So we can't hold our breath on this.
But you still believe it may come?
We have another question here. Bernardine.
Thank you very much. Are there energy solutions addressing issues to do with energy for cooking in order to save trees, especially for the poor in the developing world? Thank you.
Yes, very shortly, there are cook stoves that are much, much more efficient, that use 3, 5, 10 times less fuel, because when you have open fire cooking, lots of indoor air pollution, it's also bad for human health, and it denudes the landscape. And so in developing world, you still are going to be rummaging around for, grasses, things like that. But you start with much more efficient cook stoves. And then finally, things that capture solar heat that allow you to cook by concentrating the heat.
So the final question by Dr. Benner.
Yeah, I mean, this energy has been so politicized, it's very hard to believe anybody, and I'm always looking for bias in these presentations. If you were from France, you would have mentioned nuclear power, conventional nuclear power, they have overwhelming majority of their fixed energy sources is nuclear. Ever since 3 Mile Island, the United States political culture seems to not be able to touch nuclear power, even in its more advanced version. So in your entire talk, you never mentioned nuclear power as an alternative. Why is that?
They didn't give me enough time. But very quickly, if you look at the energy you can turn on and off will have to be probably 1/3 of the energy of the world, no matter what. You can't store that much, and so that gives only two alternatives. It's either fossil fuel, where you capture the carbon, and then you have to sequester it, or nuclear power. Possibly fusion, but that's very, it's a long shot. And so I think the last third of the energy of the world has to come from something you turn on and off. And so I actually favor nuclear for that reason. It's not as bad as coal.
Let us thank all the speakers for a very instructive session in the morning. And let's have